Now, topic the second, parallel lines and transversals. So look at the diagram I have here. What you see here are lines J and K being intersected by a single line, and we call this line the transversal. Now, this transversal, as you can see, makes 8 angles as it crosses through these two lines. In these 8 angles, we have 4 different types of special pairs. The first special pair we call corresponding angles. An example of that would be angles 1 and angle 5. As you can see, they're stacked on top of each other like a McDouble or something. Another example would be angle 4 and angle 8. Now, based upon this pattern, do you see 2 more pairs? I do. Well, I'll start you off. Angle 2. And what would go with angle 2? No. Yes, thank you. Angle 6. Angles 2 and 6 are corresponding angles, leaving angles 3 and angle 7. So those are our corresponding angles. Our next pair of special angles are called alternate interior angles. And so with that name, it tells us the angles are on the inside between the two lines we're given and alternate on alternate sides. So, for example, if I give you one of these angles on the inside, let's say angle 4, its alternate interior angle must be angle 6. It's on the inside, interior, and on the alternate side, alternate interior. The last pair would be angle 5 and angle 3. So these are our 2 pairs of alternate interior angles. So, based upon what you've seen here, can you guess what our third special pair of angles would be? If not alternate interior, it would be, boom, alternate exterior angles. So, one of our exterior angles, an angle that's not on the inside in between these two lines, J and K, would be angle 1. So what would be alternate and on the outside? Alternate and on the outside. Take a guess. Nope. Yep, there you go. 1 and 7, alternate exterior angles. Our second pair would be angle 2 and angle 8. Perfect. Now, our last and fourth special pair of angles is a little bit different. We call these consecutive angles, which just means they're right next to each other. Consecutive, they're on the inside and they're right next to each other. So for example, angle 4. I want something on the same side right next to it, on the inside. So that would be angle 5. Look at that, 4 and 5 consecutive. So our second pair of consecutive angles would be, don't get this wrong. Yes, and oh my gosh. Yes, thank you. 6 and 3. So these are 2 pairs of consecutive angles. Now, if you've noticed, as I've been revealing these special angles, some of them are color coded and some of them have the same color. Well, there's a reason for this. What we need to know about corresponding angles is that corresponding angles, when lines are parallel, corresponding angles are congruent. And if you notice that the corresponding angles are the same color, like 1 and 5, or 4 and 8. So we say corresponding angles are congruent. It's a congruent symbol when lines are parallel. Alternate interior angles, let's look at that, like 4 and 6, or 3 and 5, same color. So alternate interior angles, when lines are parallel, they are also congruent. Alternate exterior angles, like 1 and 7, or 2 and 8, they're the same color. So when lines are parallel, alternate exterior angles are congruent. Last one, the one I said was a little bit different, consecutive angles. You see, these are the only ones that are different colors, like 4 and 5, 3 and 6. So they're not congruent. They're supplementary. They add to 180 degrees. One way to remember this is I like to say assign one color to be A and one color to be B. ABBA. So A is that color, so then this is also A. B is the other color, this, B. This might help you remember this. We know A equals A, B equals B, and A and B are supplementary. We say add to 180 degrees.